Hello ladies and gentlemen, this is Mr. Cunningham. We're going to be doing a lesson today, which is a lesson 11.3, which is over limiting reactant and stoichiometry. So please take a minute or two and try and do that bell work question, and then you can come back and watch the video over lesson 11.3. Alright, now that you've finished that bell work problem, again, what we're going to be looking at today is basically what you did in your bell work. In your bell work, you looked at finding basically something called the limiting reactant. In your bell work, there was an ingredient that limited how many cookies you could make. The exact same thing happens in chemistry. All right. So here's our goals and our sub-objectives for today. First thing, sub-objective 1, you should be able to determine the limiting reactant of a reaction. All right? It's the first thing you should be able to do today. Second thing, sub-objective 2, you should be able to determine the percent yield of a reaction. And the third thing, your goal, kind of the thing I want you to be able to do for me, is be able to determine the amount produced from a chemical reaction using the limiting reactant. All right? So this is our goal for today. This is the question, the thing that we're going to be able to answer by the end of the day today. So we have a reaction, and here's our problem. Basically, what I'm going to ask you to do is I'm going to ask you to determine the limiting reactant or limiting reagent and the percent yield of aluminum iodide if one starts with 1.2 moles of aluminum and 2.4 moles of iodine, and it says if our experimental yield is 470 grams of AlI3. So right now you might be like, whoa, that's a lot of numbers. Don't worry, we'll walk through this, and we'll get this by the end of the day. So first thing, just like in our bell work, when you have like your eggs, your milk, all the ingredients to make your cookies, you usually don't have the exact amounts to make all the cookies. Usually you have some leftovers. So when two reactants mix, just like in baking, as they do in chemistry, when two reactants mix, it's very likely that one of those things is going to run out first. Okay, they're not all going to get used up at exactly the same time. There's probably going to be one that gets used up first. When that reactant runs out, when any of the reactants runs out, the reaction automatically stops because there's no more fuel, there's nothing else for it to react with. So that your reaction stops. Okay? So the question that we have is, and that we're trying to answer is, how do we know which one of those things runs out first? Because that's going to affect our calculations. All right? Here's how we know. You don't know until you actually figure out how much product each reactant will form. All right? So you're going to actually have to do two separate problems. So in our initial problem, we were given 2 mole amounts. We were given moles of aluminum and moles of iodine. We were given 2 amounts. What you're going to have to do is, you're going to have to do a calculation, stoichiometry, using your moles of iodine and your moles of aluminum, and you're going to have to look at how much of each product is formed, and you're going to have to make a conclusion based on those 2 numbers. Okay? The lower amount of product that is formed is always going to be your answer. Because the one that produces the least amount of product is the one that's going to limit the reaction. Alrighty? So, the reactant that runs out first, which is the one that gives the smaller amount of product, is the one called the limiting reactant. Alright? Or limiting reagent. The other one is one that we call the excess reactant. Okay, so the limiting reactant is the one that's going to limit the reaction. It's the one that's going to run out first. So whatever number is your lowest amount of product is the one that's your limiting reactant, and that's the number that you're going to use. So let's say, again, going back to our bell work, let's say you're baking some cookies. You want to make as many cookies as possible, and you have plenty of flour, sugar, baking soda, vanilla, milk, but you've only got 2 eggs. The number of cookies will depend on the eggs. It doesn't matter if you had an entire boat full of milk, if you've only got 2 eggs, your amount of cookies that you're going to make is going to depend on your eggs, because it's the one that's going to limit the reaction, because you have to have eggs in order to make cookies. When all the eggs get used up, the number of cookies, the production of cookies is going to stop, because you don't have any more eggs to make the cookies. You'll have excess of everything else. The eggs are your limiting reactant, because they're the ones that keep your reaction from proceeding. They are the thing that keep you from making more cookies. All right? Same thing happens in chemistry. So let's go back and look at our reaction. So here's what you do. Okay? We have to do, again, 2 calculations. As I read through my problem, remember what we've been doing in stoichiometry is we've been, first of all, balancing the chemical equation. Check, the equation is balanced. The second thing we've been doing is identifying what we're given. Okay? Well, we are given that we start with 1.2 moles of aluminum and 2.4 moles of iodine. So I am given 2 amounts. So typically we label those with an A, meaning that's our given amount. And it wants us to determine the limiting reactant and the percent yield. So we'll talk about percent yield here in a second. So if I want to figure out which one of these is the limiting reactant, I am going to go, okay, I'm going to figure out if I use this many moles of aluminum, 1.2, I'm going to solve to see how many grams of AlI3 I get. Then I'm going to do another problem, except now I'm going to use my 2.4 moles of iodine. And I'm going to go, okay, how many grams of AlI3 will I get? So I'm going to have to do 2 separate problems. The one that produces the smallest number, the smallest mass of AlI3 is my correct answer. Okay, because the one that produces the smallest amount is my limiting reactant, which means it's going to run out first. So here we go. First thing I'm going to do is I'm going to do my aluminum calculation. So I have 1.2 moles of aluminum. Because I remember in stoichiometry we always use that mole map. So the first step is I'm in moles of A. I need to get to moles of B. How I change from moles of A to moles of B using your mole map. So if you need to take out your 11.2 notes, one that has the big mole map on the front, we're changing from moles of A to moles of B. So how I do that is multiply by B over A. Well, I labeled AlI3 as B. Al is labeled as A. So I do B over A. So it's 2 over 2 because their coefficients are 2. 2 over 2. Now I am in moles of B, so now I need to change to grams of B. So how I change to grams of a substance is I multiply by its molar mass. Well, the molar mass of AlI3 is 407.7 grams for every 1 mole. So I am going to do 1.2 times 2 divided by 2 times 407.7. That gives me how many grams of AlI3 I should produce. And that's 489.24 grams. Now, a lot of students, like this is what you've been doing in stoichiometry so far. And you just be like, oh, this is how much I should get. But we don't know that for sure. We have to now do a similar calculation with my iodine because I had 2.4 moles of it. So now I'm going to do that. So now I go, okay, I've got 2.4 moles of iodine. I'm starting in moles of A. All right, I'm in moles of iodine. Again, I don't know which substance I need to use. I don't know which one is the limiting reactant yet. So that's why I have to do these 2 separate calculations. So I'm going to go 2.4 moles of iodine. I'm in moles of A. I need to change them to moles of B. How I change to moles of B is by multiplying by the mole ratio. So B is labeled as AlI3, so it's 2. So that's why I put this 2. And then over A, because I'm using iodine now, its coefficient is 3. So over 3 moles of I2. So this is B over A. So I'm changing from moles of A to moles of B. Now I would be in moles of B. Next step is I need to multiply by the molar mass of my substance B. Well, my substance B hasn't changed. It's still the same as in the last problem. It's AlI3. So it has the same molar mass. I'm going to do this calculation. I'm going to do 2.4 times 2 divided by 3 times 407.7. And what that gives me is, that gives me my amount of AlI3 that would be produced if I had used my iodine. All right, now here's where we have to make a decision. If I used my aluminum, I got 489.24 grams. If I used my 2.4 moles of iodine, I got 652.32 grams. Remember, the smaller amount of product is my limiting reactant. That means this is my limiting reactant. Now, not ALI3. I'm showing you this is the smallest number, which means my limiting reactant is aluminum. Okay? So, the substance that produces the smallest amount of product is my limiting reactant. So that means, since it said determine the limiting reagent or limiting reactant, that means I would say aluminum is my limiting reactant. Okay, so this is the amount of product that would be formed theoretically in this reaction. All right? Now, the next part is, what if we had to find the percent yield? Because it said determine the limiting reactant. Check, we've done that. Step 1 is complete. We found what the limiting reactant was. We said it's aluminum. Step 2, it also says we have to find the percent yield. Here's how you find percent yield of a reaction. Okay? Percent yield of a reaction is the experimental yield, which is how much you actually got, divided by the theoretical yield, how much you should have gotten. And again, to change it to a percent, just like in last unit, we multiply by 100 to change it to a percent. So here's an example question. We're gonna like cut away from that problem we just did, and we're gonna look at another one. So let's say that you expected to get 4.87 grams from doing a stoichiometry problem. But when you actually did it in the lab, like you actually did it yourself, you only got 2.92 grams of that product. So what we're going to do is we're going to take our experimental yield divided by our theoretical yield times 100, and that's going to give us our percent yield. So the theoretical is the amount you get when you do the stoichiometry. That's when you do the calculations. The experimental is the amount you get by actually doing the experiment. So here's how I would do this percent yield. Remember, in this example, okay, so in the previous slide, 4.87 grams was the answer to my stoichiometry problem. That is my theoretical amount. But I only got 2.92 grams when I did the reaction, when I actually did it experimentally. So to find my percent yield, I would take my experimental amount, 2.92 grams, divided by my theoretical amount, 4.87 grams, and then multiply by 100, and that's going to give me my percent yield. So in this example, my percent yield would be 59.9%. All right? Because I took my experimental, how much I actually got from doing the reaction, divided by theoretical times 100, that's my percent yield. So now let's cut back to our problem. So remember, we said this aluminum was my limiting reactant, which means theoretically I should produce this much aluminum iodide. I should get 489.24 grams of aluminum iodide. But if I go back and look in the problem, it said if the experimental yield is 470 grams of ALI3. So I did the reaction, and I only got 470 grams. Here's what I was supposed to get. Here's what I actually got. So what I'm going to do is I'm going to use that percent yield equation. Experimental divided by theoretical times 100 is my percent yield. So I'm going to take my experimental, find it, circle it, experimental, divided by theoretical. My theoretical is how much I got by doing my calculation. That is going to be my 489.24. Experimental divided by theoretical, now times 100. And that gives me that my percent yield is 96.07%, meaning I got 96.07% of what I thought I would get. Okay? That's what a percent yield means. How much you got compared to how much you were expecting to get, how much you should have gotten. Okay? So, you might say, wow, that was a lot of steps. And you might ask, is there an easier way to determine the limiting reactant? The answer is yes, there is. So, I'm getting ready to show you another way to determine the limiting reactant that is a little bit shorter, You can choose whichever way you want. Really, it depends on what purpose you're trying to use it for. So here's another way, okay? Another way to find the limiting reactant is you find moles of each given substance. So in our first problem, remember we were given moles of aluminum and moles of iodine. So we had 2 given substances. So I find moles of each of those substances and I divide by the coefficient in front of each substance from the balanced equation. The smaller number is your limiting reactant. Okay? That means you do like half of the work, and that means you do the calculation using the given amount of the substance that gave you the lowest number. Okay, so the shorter way to do it is find moles of each of my given substances and divide by their coefficient from the balanced equation. The one that produces the smallest number is my limiting reactant, and that's the one that I'm going to use the given amount for. So let's walk through that. I'm going to show you exactly how to do that. So here's our problem. It says calculate the number of grams of silver chloride produced when 2.55 grams of silver nitrate reacts with 0.93 grams of calcium chloride. So here's what I need to do in every stoichiometry problem. Step 1, balance. So I've gone through and I've balanced my equation. Step 2, label your given substances and your desired substances. Well, it gave me 2.55 grams of silver nitrate. Silver nitrate is right here, so that's a given substance. Second thing is that I was given 0.93 grams of calcium chloride. This is calcium chloride, so I also label it as substance A. Then I have to go, okay, what's it asking me to find? Well, it's asking me to find the number of grams of silver chloride. This is silver chloride, that's why I labeled it as substance B. So now I'm going to use that quicker method to determine the limiting reactant. So, first thing is, I start with my given amount of, I'm going to use my silver nitrate first. So, I'm going to find the moles of silver nitrate I have. So, I'm going to take my 2.55 grams, and I need to divide by the molar mass of silver nitrate. That's going to give me moles of silver nitrate. So I have 0.015 moles of silver nitrate. Now I'm going to find my moles of calcium chloride because that's my other given substance. So I started with 0.93 grams of calcium chloride, and I'm going to divide by its molar mass to get to moles. I have 0.009 moles of calcium chloride. I now have moles of each substance. That's the first thing. Next step is now I divide by the coefficient from the balanced equation. So, because silver nitrate has a 2 in front of it, I'm going to divide this number by 2. Because calcium chloride has no coefficient in front of it, I would divide this by 1. Now I look at which one of these produced the smaller number. This one is the smaller number, which means silver nitrate is my limiting reactant, which means I'm going to use this starting value to do my entire calculation, which means this is out. I can basically ignore my calcium chloride now. I don't need it because I've determined that silver nitrate is my limiting reactant, so I'm going to use that number. Alrighty? So, now let's finish our problem. Because it said, calculate the number of grams of silver chloride. In order to do that, I first had to determine which one was my limiting reactant that I needed to use. So now I'm going to take my 2.55 grams of silver nitrate, change and use my mole map. I'm going to change from grams to moles. How I change from grams to moles is by dividing by the molar mass. So I divide by the molar mass. Then to change from moles of A to moles of B, I need to look at the mole ratio. Well, the mole ratio is I have 2 moles of silver chloride for every 2 moles of silver nitrate. So my mole ratio there is 2/2. Next step is, because it says calculate the number of grams of silver chloride, now I need to change from moles of B to grams of B. How I change from from moles to grams is by multiplying by the molar mass of substance B. Substance B is silver chloride. So I need to find its molar mass, and I'm going to multiply by it. So I multiply by the molar mass of silver chloride. So I would do 2.55 divided by 169.87 times 2 divided by 2 times 143.32, and that gives me 2.15 grams of silver chloride. Here's what that means. That means using this limiting reactant, this is the one that's going to limit the reaction, it's the one that's going to run out first, which means the amount of silver chloride that I should actually get is 2.15 grams. Okay, so that's both ways. So in review, all right, shown you 3 things. So if you are given 2 amounts of reactants, so if you're given 2 amounts and you look in your equation and they're both reactants, to find the limiting reactant, see which starting value gives you the smallest amount of products. The limiting reactant is the compound that gave you the smallest amount of product. Okay, that's the first way, the first thing I showed you. Second thing, another way to do a limiting reactant problem is to find moles of each reactant, so moles of your given amounts, and divide by the coefficient of the compound in the balanced equation. The one that produces the lowest number is your limiting reactant. Then you do your problem using that given substance. Then the other thing that I showed you to do is how to find the percent yield of a reaction. To find the percent yield, take the actual amount produced from the reaction, which we call the experimental, and divide by the amount you should have gotten from your calculation and from your stoichiometry. That's called our theoretical, and then I multiply that number by 100. That gives me my percent yield. So what I want you guys to try now is, I have a practice problem that I want you to try at the bottom of your page. Please give that a shot. If you have any questions, please make sure you check it with me, ask me. If you need to review the video, obviously you can rewind. Thanks for watching.